All right, moving on with gas behavior, we are going to look at some laws. Again, this is probably the hardest section of the chapter, so if you have to watch these videos again, please do so. But these are gas laws. Our first law we are going to talk about is Boyle's law. Boyle's law is a relationship between pressure and volume. So remember, in gases, temperature and pressure and volume are all related. These are the ways we describe what's happening. So Boyle's law is between pressure and volume. The one we leave out, temperature, is going to remain constant here. We're going to use that as a constant, so temperature is not changing. So you can see in our description here, our temperature is not going to change. Boyle's law states, as you increase pressure, you decrease volume, or as you decrease volume, you increase pressure. So depending on which one you change, the other one is going to change in an inverse relationship. So pressure goes up, volume goes down. Pressure goes down, volume goes up. It is an inverse relationship there. So as one goes up, the other goes down. Keep that in mind. Boyle's law has the inverse relationship. So we are going to look at Boyle's law. When I increase pressure, I decrease volume. So if you imagine you have that basketball and you're really, really strong and you want to squeeze that basketball, you're going to squeeze that basketball so hard, you're going to decrease the volume of that basketball. In doing so, you're going to allow less space for those particles to move around in. The less space they have, the more collisions they're going to get. And then remember, collisions are pressure. So anytime it collides with either the wall of the basketball or another particle inside the basketball, you get pressure. So if I squeeze that basketball, I'm going to increase pressure. Or vice versa, if I decrease the pressure, if I take air out of that basketball, if I start to deflate it, right, I'm going to get less air particles. Less air particles means less collisions, and therefore going to decrease the volume. And as you deflate your basketball's volume goes down. So this is Boyle's law. Keep in mind it is our inverse relationship. Our second of three laws does not have a fancy name to it, but it relates pressure and temperature. So again, pressure and temperature are being related, which means volume, our third factor, is going to be remaining constant. So I can't change my volume. I can only increase temperature or increase pressure or decrease one or the other. With this, it is a direct relationship. So as one goes up, the other goes up. If I increase temperature, then I increase the speed and movement of those particles. And the faster they're moving, the more collisions they're going to have. And therefore, collisions are pressure. You're going to get more pressure from it. If I decrease the temperature, I'm going to slow down those particles. And as I slow them down, I'm going to get less and less collisions. You can think of it as bumper cars if you want. The more speed and movement of those bumper cars, the faster they're going, then you can think of that as an increase in temperature, like the particles. The more collisions they're going to have with each other, or the sides of the little area that you have to play bumper cars in. So you're going to increase temperature, increase movement, and therefore increase pressure, which is the collisions. So you increase the collisions. So high temperatures mean faster particles mean faster movement, and therefore they hit more often. Our last law is Charles' law. Charles' law relates our two variables of volume and temperature. This is again a direct relationship, so as one increases, the other will also increase. And keeping in mind this is volume and temperature, so in this case pressure is your constant. We're not changing pressure at all here. So as I increase the temperature, in order to have the same amount of collisions, I need to increase the volume or the space that is available for these particles to move around in. So as temperature increases, volume is going to increase. As temperature decreases, volume will also decrease. Because again, I want to try to keep those collisions, that pressure, at a constant amount. So in order to do so, if I decrease temperature, I have to decrease the volume in order to have the same amount of collisions. Again, decreasing the volume is going to make it a tighter area for all those particles to move in, and therefore they'll be hitting the walls more often. You'll notice in your assignment sheet that this chapter only has 3 major projects for you. And that is because one of the major projects I'm not going to give you a choice to do, and I put at the very bottom there, and that is a simulation going between Charles and Boyle's law, just to help you better understand this concept, because I do think these are probably the most confusing parts of this chapter. So I'm not giving you a choice on what to pick there. The other project you are welcome to choose, and therefore I've actually only narrowed it down to 1 out of 3 this time. Please make sure you're doing your section assessments. Please make sure you're studying your vocabulary. And this will conclude our videos for Chapter 2.